Hello students, today we are going to start the third part of the chapter Understanding Quadrilaterals for class 8. So let us begin. First we will discuss about the characteristics or properties of the special parallelograms, and then we will move towards solving the exercise related questions. So first special kind of parallelogram we are discussing today is a rectangle. Now we are talking about quadrilaterals. So you all know that we are discussing about four-sided figures. So when I'm talking about a rectangle, the opposite sides of the rectangle are equal. If ABCD is a rectangle and these are the diagonals AC and BD, all the angles of a rectangle are 90 degree. The properties of a rectangle are that the interior angles of a rectangle, that is angle A, angle B, angle C and angle D, all are equal to 90 degree. The symbol that I represent here shows that it is 90 degree each. And the diagonals of a rectangle are equal. Please remember the diagonals here. AC is equal to BD. And all the angles, angle A equal to angle B, equal to angle C, equal to angle D is equal to 90 degree. This is the property of a rectangle. The next quadrilateral that we are discussing is a rhombus. Now, if two adjacent sides of a parallelogram are equal, then it is a rhombus. Now here AB is equal to BC is equal to DC equal to AD. This is a rhombus. Is more or less like a square which is tilted, but in the square the sides are 90 degree. In a rhombus it is not. So adjacent sides, so here AB is equal to AC, these are the adjacent side which are equal, and all the sides of a rhombus are equal. So I can write AB is equal to BC is equal to CD equal to AD or DA, and the diagonals of a rhombus bisect or intersect at 90 degree. So here if I call this as O, then angle AOB or angle BOC or COD and DOA all are 90 degree. So the diagonals of a rhombus intersect at 90 degree or at right angles. And also the diagonals bisect the angle. Bisect the angle means if this is 30 degree, then the other side is also 30 degree. So it's bisecting the angle, means dividing the angle into two equal parts. So if I say you that BAO is 30, then OAD is also 30 degree. These are the properties of a rhombus. Next we will discuss about the square. If two adjacent sides of a rectangle are equal, then it is becoming a square. So in a square, you know that AB is equal to BC equal to CD equal to DA. All the sides are equal. Also, it has the properties which are very similar to those of a rhombus, like all the interior angles are 90 degree. So here also I can say that angle A is equal to angle B equal to angle C equal to angle D, that is 90 degree, just like a rectangle. All the sides are equal, so I can say AB is equal to BC equal to DC equal to DA. The diagonals of a square are also equal, so the diagonals of a square are also equal, that is AC is equal to BD, and even the diagonals bisect at right angle. So here it is forming 90 degree. So same as the rhombus, I had told you the diagonals bisect at 90 degree or right angles, same happens in a square. So I can say that AC is perpendicular to BD. And the last property is that the diagonals bisect the angles of a square. So here again the angles are divided into equal halves because the angles are bisected because of the diagonals. Now the next special kind of the quadrilateral that we are going to discuss are the trapezium. Here I have drawn two diagrams of a trapezium, ABCD and again ABCD. The difference between these trapeziums are This is a normal trapezium. In a trapezium, it is a quadrilateral in which one pair of opposite side is parallel. So here AB is parallel to DC. Same is in this trapezium, which is called an isosceles trapezium. In an isosceles trapezium, the opposite sides are parallel and the non-parallel sides are equal. So here AD will be equal to CB. AD is equal to CB. So that becomes a isosceles trapezium. In both of them, as the opposite one pair is parallel, and suppose we assume that this AD here, the AD, they are the transversal, then I can say that the sum of A plus D is equal to 180 degree, because they are forming a co-interior angle of parallel line. The co-interior angles where two parallel lines and a transversal passes through them. So in a normal trapezium, A plus D is equal to 180, B plus C is equal to 180. Some special features add when it is an isosceles trapezium, that is A plus D is 180 like the previous case, but here the angles on the same basis are equal. Now when I say angles on the same basis, here angle A is equal to angle B because they are on the same base, and angle D is equal to angle C as they are on the same base. So remember, in an isosceles trapezium, angle A is equal to angle B and angle D is equal to angle C. You need to remember these properties as you will be solving questions based on the properties of these quadrilaterals. And in this figure, you know that the AC is equal to BD because the diagonals are of equal length in this case, isosceles triangle. AC is equal to BD, that is the diagonals are of equal length. Now talking about the next quadrilateral, that is a kite. All these are having four sides, so that is why we are calling them quadrilateral. So a quadrilateral in which two pairs of adjacent sides are equal are called the kite. So here AD is equal to DC and AB is equal to BC, but they both are not equal to each other. The adjacent sides are equal. And in a kite, the properties are as follows. The diagonals of a kite intersect at 90 degree. As you can see, I have drawn a 90 degree here. So the AC is perpendicular to BD. So they are intersecting at 90 degree. In this, A angle is equal to angle C. The whole A angle is equal to angle C. If I tell that this is O, then OA and OC are same, equal. OA and OC are equal. And the diagonal BD bisects D and B. So D and B are bisected by the diagonal BD. So BD is the diagonal which bisects the angle B and D. Means if this is known, we can multiply it 2 times to get the answer. If you know this side, you can get the other side because they will be same, as BD bisects angle B and D. And in this diagram, BD is dividing the kite into two congruent triangles, ABD and CBD. You can see that AD is equal to AC, AB is equal to BC, and the line or the diagonal BD is common in both. So the SSS, side axiom of congruency, can be met. So we can say that triangle ADB is congruent to triangle BDC in a kite. So using this concepts and properties of the different quadrilaterals, let us now solve a few questions. In the given question, you can see that in the adjoining figure ABCD is a rhombus. You have to find the value of X, Y and Z. So according to the properties of a rhombus, we know that the diagonals of a rhombus bisect at 90 degree. So if I call this O, then angle DOC is equal to 90 degree. Using the Pythagoras theorem, I can easily get the value of DC. DC square will be OC square plus OD square, which is equal to OC is 8 square plus OD is 6 square, that is 64 plus 36 equal to 100. So to get DC, we do the root over and we get DC as 10 centimeter. If DC is 10, obviously the side Z is equal to 10 centimeter, as DC is equal to AB, as it is a rhombus. Our next part is to find X and Y. X is equal to 8 centimeter because we have discussed the characteristic of a rhombus, that a rhombus is having diagonals equal. So this part is equal to this part. So X is equal to 8 and Y is equal to 6 centimeter. As the diagonals are bisected, the diagonal values are same. So X is equal to 8 and Y is equal to 6 and Z is equal to 10 centimeter using the Pythagoras theorem. As this is a 90 degree, any angle opposite to 90 degree is the longest side, and we add the other two sides square so that we get the hypotenuse value of the given diagram. Now in the given question, ABCD is a rectangle and it is telling that CEB is 3 and ECB is 2. So I can represent it as 3x and 2x. So let us write, let angle CEB and angle ECB be 3x and 2x. So you can see the triangle ECB, and you know the property of a triangle, that the sum of the angles of a triangle is equal to 180 degree. Now angle B is 90 degree. So angle B equal to 90 degree as it is a part of rectangle ABCD, and the angles of a rectangle are 90 degree. So now I am going to add the three values. 3x plus 2x plus 90 equal to 180 degree, because that is sum of a triangle, sum of angles of a triangle. So here I get 5x, 180 minus 90. I solve x, 90 by 5, that is 18 degree. I don't want only x, I want the value of CEB, which is 3x. So angle CEB is equal to 3x, which is equal to 3 into 18, that is 54 degree. So I got one answer, and the bit 2 is angle DCF, which is marked here DCF. So for that we can first calculate DCE. So DCE plus DCF are the linear pairs, because it is a straight line, and that is equal to 180 degree. So to get DCE, I can minus 90, because you know angle C is a part of the rectangle, which will be 90 minus 2x, that is 2 into 18. So DCE is equal to, first let us calculate DCE, to 90 minus 2 into 18, that is 90 minus 36 equal to 54 degree. So to get the value of DCF, I have calculated 2x, which was 36, and subtracted 180 minus 54, and subtracted 180 minus 54 to get 126. So angle DCF is 126. In our next question, we have to find the value of the rhombus ABCD, where angle ABD is 50. We have to find angle CAB, that is this one. Then angle BCD and angle ADC. So in a rhombus, you know that the diagonals bisect at 90 degree. So you know that all these angles are 90 degree. So using that property, and if I call the center as O, in triangle AOB, angle B is 50 degree given to us. Angle AOB is equal to 90 degree. Diagonal of a rhombus intersect at 90 degree, and we have to find angle OAB. So you know that the sum of the three angles of a triangle is 180 degree. So I can write this angle OAB plus 50 plus 90 degrees equal to 180 degree, sum of angles of a triangle. So I get angle OAB as 180 minus 140, that is 40 degree. So my first answer is angle CAB is 40 degree. Now you know that these are all parallel to each other. So if I consider this as a transversal CA, then angle OCD is also going to be 40 degree. Triangle angle OCD is equal to 40 degree, as OCD is equal to CAB, as we are forming the alternate angle. This is happening because the sides are parallel and this is acting as a transversal. And you know that we have to find angle BCD. So angle BCD is going to be double of angle OCD, because the diagonals bisect the angles of a rhombus, that is 80 degree. The reason being diagonals bisect the angle. After we get this, we go to the last one, that is angle ADC. So we know that this side is 50, so other side of this triangle, this angle, that is ODC, from this side it is going to be 50 degrees. So if I say ODC equal to OBA, that is 50 degree, again the reason being same as this, alternate angle, then 2 into ODC, that is 50 into 2 is 100 degree, will be the answer of ADC, angle ADC. So I am very sure you are able to understand how, using the concept of parallel lines and the properties of rhombus, we are able to solve this question. In our next question, we have an isosceles trapezium with side ABCD, where angle C is 102 degree, and we have to find all the other angles of a trapezium. So this is an isosceles trapezium, and if you remember the property that the base angles of an isosceles triangles are same. So I can say that angle C is equal to angle D, that is 102. This is base angles of an isosceles trapezium. AB is also the base angle, and angle B plus 102 degree is equal to 180 degree, because it is a co-interior angle, you can say, if I consider that these two are the parallel lines, trapezium. So angle B is equal to 180 minus 102, that is 78 degree. So once angle A is equal to angle B, that is 78 degree. The reason being, base angles of an isosceles triangle are same. So thus we got A, B 78 and D is equal to 102. In the next question, we have a kite with diagonal BD and AC, and the diagonals are bisecting at angle O. Angle ABO is equal to 32 degree and OCD is equal to 40 degree. We have to find some given angles. So starting with ABC is double of ABO. 2 into angle ABO, that is 2 into 32 degree, that is 64 degree. This is because the diagonals BD is bisecting angle B. So for finding this, we can tell that this is also, other side is also 32, and that forms 64. For angle ADC, this full angle. Now you know that DOC is equal to 90 degree because the diagonals of a kite bisect at 90 degree perpendicular to AC. So DOC plus the 40 degree given to us plus ODC, can calculate angle ODC plus 40 degree plus 90 degree is equal to 180 degree. So angle ODC is equal to 180 minus 130, that is 50 degree, and twice of ODC is ADC, that is 50 into 2, 100 degree. So angle ADC is twice of angle ODC because they are again BD perpendicular to AC and they are bisecting the angles. And to find the last one, that is BAD, for angle BAD, you already know this is 50, this is 90. So angle ADO plus angle AOD plus angle DAO equal to 180 degrees. So this is 50 plus 90 plus DAO is equal to 180 because that's forming another triangle. So angle DAO is equal to 180 minus 140, that is 40 degree. So this is 40 degree and I can easily get this value. So to get the angle OAP, so that we can add this to, let us consider this triangle AOB. So triangle AOB is telling me that 32 plus 90 degree because the bisected 90 degrees there plus angle OAB is equal to 180 degrees. So OAB is equal to 180 minus 122, that is 58 degree. So our answer, angle BAD will be equal to angle DAO plus angle OAB, which is 40 plus 58 is equal to 98 degree. So like this we are able to solve the questions related to the kite. So I am very sure now you will be able to solve problems related to quadrilateral, different kinds like rectangle, square, rhombus, kite, trapezium, isosceles trapezium. Please see that you learn the properties well. If you remember the properties, it will be easy for you to solve any related question. Do let me know if you understood the different quadrilateral sums, and don't forget to like, share and comment. And if you haven't subscribed yet, please do press on the bell icon. Thank you.